Hey guys, welcome to day 4 of At Home Learning. It's a great day to be a mathematician. We get to learn about the perimeters and areas of similar figures. This section kind of takes a little bit of a shift from what we've been looking at before. We're getting back to more of ratios and scale factors and things like that. So there's really just two things you need to know. If the scale factor of two similar figures is some number to some other number, then the ratio of their perimeters would also be the same. And the ratio of their areas, you'd actually take those numbers and square them to apply stuff to areas. And that one we'll see an example of in just a little bit. So if you look at our first example problems, it says that these two figures are similar. Remember, that's the symbol for similar. It says first find the scale factor of the larger figure to the smaller figure. So remember, to do that, very simple. You just find corresponding sides and set up a ratio, a fraction, or whatever you want to do, and just make sure to reduce that. So it says the larger one's first, the smaller one is second, so that's going to be 15 to 12. And then you want to reduce that. They're both divisible by 3. So really the ratio is 5 to 4. The scale factor is 5 to 4. So we can use that to help us find AB. So you would take your scale factor, 5 to 4, and we're going to set up a proportion with it. So AB corresponds to the bigger figure. So remember, we put the bigger figure on top, the smaller figure on bottom. So AB is going to be the top number. And what side corresponds to AB in the other figure? That would be side GF, which they tell us is 4. So this one's pretty apparent that AB is 5, but if you don't remember how you would go about finding that, you cross multiply on proportions. So it would say 4AB equals 20, and divide by 4, and AB is 5. But it's pretty obvious when the denominators are the same that the numerators are going to be the same as well. So AB would be 5. The next thing they ask is find the ratio of the perimeters of the larger figure to the smaller figure. So remember, the ratio of the perimeter is the same as the scale factor. So since the scale factor was 5 to 4, the ratio of the perimeters is also going to be 5 to 4. The ratio of the areas, you just take the ratio of the perimeters or the scale factor and you square it. So that means the ratio of the areas is going to be 25 to 16. That's 5 squared and 4 squared. So we can use that type of information on problems like this. It says the area of the smaller regular pentagon is about 27.5 square centimeters. We want to know what is the approximate area of the larger regular pentagon. So first thing that you need to know is, what's the scale factor between the smaller and the larger one? So as a fraction, it's 4 over 10, but that's going to reduce, and it's going to reduce to 2/5, right? So we're dealing with areas, so the areas, we would square this fraction. So 2 squared is 4, 4 squared is 25. Okay, so that's the proportion, or the ratio that we're going to use to set up our proportion. So it says the area of the smaller pentagon is 27.5. So that's going to correspond to the small number, which was on top in our ratio. And we want to know what's the approximate area of the larger pentagon. So that's going to be our x. So easy enough to cross multiply that. 4 times x is going to be 4x. 25 times 27.5, let's see, 25 times 27.5 comes out to be 687.5. Divide that by 4. X comes out to be 171.875. It says to approximate that. So we'll call it approximately, they rounded to the nearest tenth, so we'll round to the nearest tenth as well. 171.9 square centimeters. So that's how you do that. This is not too difficult stuff. Here's another problem. It says, during the summer, a group of high school students cultivated a plot of city land and harvested 13 bushels of vegetables, which they donated to a food pantry. Next summer, the city decided to let them use a larger plot of land that is similar to the previous plot of land. In the new plot, each dimension is 2.5 times the corresponding dimensions of the original plot. How many bushels can the students expect to harvest next year? So here's the thing. It's not 13 times 2.5. They have 2.5 times as much land in a single dimension both directions. So really, they have much more than 2.5 times the area of the land that they're doing. So you just kind of heard me give you a hint. It deals with area. So before they had whatever they had, we'll use it as 1 for their original plot of land. Now they have 2.5 times that. Now that is the ratio of the perimeters, right? Because that's the dimension is 2.5 times longer each way. So for the area, so this is the perimeter. For the area, we have to square each of those numbers. So 1 still stays 1. 2.5 squared is 6.25. So that's the ratio that you're going to be using. So the before number was 1. The before number that they harvested was 13. How many are they going to have this year? We don't know. So we call that x. This is real nice. Cross multiply. 1 times x is x. And then 6.25 times 13. We'll type that one into our calculators. 6.25 times 13. It comes out to be 81.25 bushels is what they can expect this year. Or next year, I guess. So that is definitely more than 2.5 times, right? 13 times 2.5 is much less than 81.25 bushels. To the back, a few more examples. Not too hard stuff today. It says the triangles to the right are similar. What is the scale factor? And what is the ratio of their perimeters? Well, we know that those questions are the same thing, right? Scale factor and the ratio of their perimeters are the same. But you notice they give us areas. So let's do the small one on top, the big one on bottom, 50 to 98. Does that fraction reduce? Absolutely. Divide it by 2, and you've got 25 or 49. Now this is the ratio of their areas, right? So how do I get back from areas to perimeters? Well, if we square perimeters to get to areas, we can take the square root of each of these to get back to the perimeter. So it's going to be 5 to 7, which is both the scale factor and the ratio of their perimeters. So if you want to pause the video here and try these next two examples, that would be good. Otherwise, you can just follow along as I explain them. So it says the scale factor of the dimensions of two similar pieces of glass is 3 to 5. The smaller piece cost $2.50. How much should the larger piece cost? Okay, so glass, once again, is not just one dimensional. It is, glass takes up an area. It's like usually a rectangle or square of some sort. So it says that their perimeter, their scale factor, is 3 to 5. So the area, however, we would square those. It's going to be 9 to 25. It says the smaller piece cost $2.50. How much would the larger piece cost? And so since they're similar and it should be priced upon how much glass is being used. This would probably be the way that they would do that. So we cross multiply that, we would get 9x equals 62.5. Divide that by 9, and you would expect that bigger piece of glass to cost, rounded to the nearest cent, $6.94. So hopefully you got that one right. This one is much like the one up above. It says the areas of two similar rectangles are those. I like to put the smaller one on top. If you put the bigger one on top, it's fine. That reduces at least by 5. Let me see what this reduces to. To 9 over 125 if you reduced that fraction. Okay, so that is the area, right? So it says what is the ratio of their perimeters? Well, to do that, you take the square root of both of those numbers. That would be 3 on top. I don't know what the square root of 125 is. So I don't know. It probably, as a decimal, it comes out to be 11.2. I'm not sure if they want like a radical. If they wanted it in simplest radical form, the square root of 125 is 25 times 5, so it would be 5 square roots of 5. So I don't know which way they want the answer, but either way, whatever they ask for in MyMathLab. So that's all you have today. Pretty easy stuff. If you have any questions, please ask, reach out to me, and I'll do my best to help you out. And good luck on MyMathLab.